The Sun.
A medium-sized yellow star, the Sun is a fiery ball of gas that measures 1,392.700 kilometers across, 109 times the diameter of Earth. Even though the Sun is made almost entirely of hydrogen and helium, the lightest gases in the universe. It weighs 2,000 trillion tons, about 300,000 times as much as Earth. The Sun's interior is heated, by nuclear fusion reactions, to temperatures of more than 15 million C. Energy is produced in the central core and very slowly works its way outwards through a thick layer C gases. In the outer layer, hot gas rises to the surface where heat and light escape into space. The heat from the Sun's interior erupts on the surface in patches called granules, and as gigantic arcs of hot gases called solar prominences. The Sun gets hot because it is so big that the pressure in its core is tremendous, enough to force the nuclei of hydrogen atoms to fuse, join together, to make helium atoms. This nuclear fusion reaction releases huge amounts of energy. Halfway between its core and its surface, the Sun is as dense as water. Closer to the surface, it becomes as dense as air.
Nuclear fusion reactions in the Sun's core convert 5 million tons of gas into energy every second, but the energy takes 10 million years to reach the surface.
Solar changes. The Sun is about 4.6 billion years old and halfway through its life. As a medium-sized star, it will probably live for around 11 billion years. Over the next few billion years, the Sun will brighten and swell until it is twice as bright and 50% bigger. The Sun seems to burn steadily, although its brightness does vary very slightly over decades. Over the next 5 billion years there will be a long-term trend for it to burn more ferociously. In 5 billion years, the Sun's hydrogen fuel will have burned out, and its core will start to shrink. As its core shrinks, the rest of the Sun will. And its surface will become cooler and redder. It will be a red giant star. Earth will have burned out long before the Sun is big enough to expand so much that it completely swell up. Swallows our planet. The Sun will end as a white dwarf, the last stage in the life of a medium-sized star. Between 1645 and 1715, few sunspots were seen on the Sun. This period is called the Maunder Minimum. At that time Earth experienced an ice age known as the Little Ice Age, due to less heat from the Sun. More of the chemical carbon-14 is made on Earth when the Sun is less active. The carbon-14 is absorbed by trees, which means scientists can track changes in solar activity in the past by measuring carbon-14 in old wood. The SOHO, Solar and Heliospheric Observatory, spacecraft is stationed between the Earth and the Sun. It monitors the Sun and changes in solar activity.